Okay, in this video, we're going to go over something called angle bisectors and the incenter, okay, which is very similar to the perpendicular bisectors and the circumcenter that we looked at in a previous video, and very similar to altitudes and the orthocenter that we saw in another video. So let's start talking about one of our vocabulary terms here, and that's the angle bisectors. Okay, so what is an angle bisector? It's really pretty straightforward. In an angle bisector, you are going from the middle of a vertex and you're cutting that angle into two equal halves. And you do that by going to the midpoint of the opposite side. So let me say that again. You're going from the vertex of one of the angles in your triangle and going to the midpoint of the opposite side. Okay? So, in order to do that, though, we need to find what the midpoint is of each of the sides of the triangle. So, one of the first things we're going to do is find, we'll call this our first paragraph in this long journey to figure out what the incenter is. Oh, by the way, the incenter is where all those lines actually meet. Okay? So first things first, let's find the midpoints of each of the sides of this triangle. And notice I put A, B, and C here as well. So let's start with line segment AB. And AB goes from -2, 4 to 3, 1. Remember that the midpoint formula is basically just add the x's and divide by 2, and you add the y's and divide by 2. All right? So let's go ahead and just start plugging numbers in quickly. So -2 plus 3, -2 plus 3 divided by 2. And for my y's, I'm going to have 4 plus 1. And again, I'm going to divide by 2. That's going to give me -2 plus 3 is +1, so 1/2. And 5 over 2 is going to give me 5 over 2. If I want to change that to decimals, it would be 0.5 and 2.5. Let's just check and make sure that's correct. So there's my half, or 0.5, and then there's my 2.5. There's my midpoint right there. Let me just go ahead and mark that in a slightly different color. Okay, so we have a little bit choice there. Now, let's try BC. Let's find this side over here. BC. You know, in doing these problems, organization is really important, right? Because you're essentially what you're doing is you're writing to me a mathematical essay, and each paragraph, if you want, of that essay is finding a very particular type of thing with calculations and text and headings and that sort of thing. So try to keep it as organized as you can. So my x is 3 and my x2 is -4. So I'm going to say 3 plus a -4, and again divide it by 2, and then 1 plus a -3, and again divided by 2. That's going to give me a -1 over 2, which is a -1/2. And that's going to give me what? -2 over 2, or -1. So -1/2, -1. Let's see if that actually makes some sense. So -1/2, -1. Sure enough, it looks like it's right there on the line. Again, I'm going to mark it into this color here. I don't know if you can actually see the red, but it's actually a red. So I found my second midpoint. Let's go for our third midpoint, and that is AC. Okay, I'm going to put it up here. So line segment or side AC is -2, -4. So -2 plus a -4 divided by 2. And then 4 plus a -3. And again divided by 2. That's going to give me -6 over 2. And that's going to give me 1 over 2. Let's reduce this one, and we get -3 and a +1/2. Okay, so -3, sure enough, 1, 2, 3, and a +1/2 right there. And again, it looks like it's dead on. So there's my other midpoint. So now what I'm going to do is I'm going to take a line and go from the middle of each of these vertices, and I'm going to draw it to the midpoint of the opposite side. Now, let's eyeball that first. Okay, I'm going to draw that by hand, and I'll show you why here in just a second. So there's that one. There's this one, and here's that one. Now, I have an approximate of where my incenter is, and again, the intersection of all three of those lines is called the incenter. Notice that it's not exactly on any one of the corners of my graph. So what do I have to do to find this mathematically? Because that's really what I'm doing here. I'm finding this angle bisector. I'm finding this incenter mathematically. All right, that's important. Mathematically. And I'm not just eyeballing it. How do I find out what this line is? Notice now, though, that I have 2 points. I've got this point, -4, -3, and this midpoint, which I said was 1/2 and 5/2. So what I'm going to do is I'm going to take both of those points. Where do I have some room here? Let's do it over here. So I'm going to call this second paragraph is finding the slope of the lines, of the angle bisectors. Let me say that again. I'm finding the slope of the angle bisectors. And if I didn't say it earlier, I think I did, but let me just make sure I've reiterated. What I've done here is I've created angles. I've basically just bisected that angle and cut it in half. So this side, this half is equal to that half. Over here, this half is equal to this half. This half is equal to that half. Okay, so that's important. You're cutting these angles directly in half. So I'm going to find slopes of the angle bisectors. Okay, and again, you can do that because you have 2 points. Let's start with this one first. Now, in order for me to do that, I probably need to give more letters here, right? So I'm going to call this C, and I'm going to call this one here D. Let's go with D. Let's make this one E, and let's make this one F, okay? So let's find the line, the slope of line CD, all right? And remember, the slope is equal to the difference in the y's divided by the difference in the x, or slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And remember, that's equal to m, the slope. Let's do the first one. -3. And we said that this midpoint here was 1/2 and 5/2. So minus 5/2, which is just 2.5. Over -4 minus 1/2, which is just 0.5. All right, let's keep going. That's going to give me a -5.5. And that's going to give me a -4.5. Now, you should never leave a fraction as a decimal over a decimal. I do know that this is going to become a positive slope, and it makes sense because it's going up, right? Because it's a negative divided by a negative. Let me just grab my calculator. calculator. And so 5.5. 5.5 divided by 4.5 gives me a slope of 1.22. I don't know if you can actually quite see that very well. 1.22 to repeating. 1.222 is my slope. I'm toying with changing that to a fraction, but for right now I think I'm just going to leave it the way it is. Okay. Once I have actually found that slope, I'm going to put one of these points and this slope into the point slope form. So let me make that my third paragraph if you want. Point slope form. Remember, the point slope form is y minus y sub 1 is equal to the slope times x minus x sub 1. I'm going to put in y minus, choose either one of these 2 points. Let's just go with, the negative 4, 3. So the y would be negative 3. My slope is 1.22. Let's just leave it like that. And then x minus a negative 4. That's going to give me y plus 3 is equal to 1.22 times x plus 4. And that's the equation of this line. Okay? Now what I'm going to do is I'm going to actually find the equation of each one of these lines, each one of these angle bisectors. And once you find the equation for each one of those lines, you can actually do, and this is going to be my step 4, I'm not going to do the equation for each one just because it's going to take too long. This video is going to take a long time. You can do one of two things. You can put this into a graphing calculator, put all 3 of them into a graphing calculator, and you should come up with a common point right there. All right, so that's step number 1, or you could do step number 1. The other thing you could do is just do a system of equations where you take all 3 of them and do a 3 by 3 system of equations, right? And then you could find out what the common point is for all 3. Or you could just take 2 of them and find out a 2 by 2 system of equations, and then whatever that common point is, you realize that it's going to be the same for all 3 of them. Okay? So do a system of equations for 2 or 3 of the lines. And again, I'm not going to do that because it's just going to take too long for this really long video. Okay, I hope that was helpful to you.